Lesson 3.5 has us graphing using a new form of an equation called slope-intercept form. Now this is the one that we're familiar with, y equals mx plus b. The reason it's called slope-intercept form is m represents the slope and b represents the y-intercept. So the name of it is what the equation tells us. And that's really useful information for graphing. This is probably one of the easiest equations we can work with, so familiarize yourself with it because you're going to see it a lot. So let's start the discussion with slope. The idea of slope is rate of change. How do I get from one place to another place? Okay, so the rate of change, all right, what I like to think of this as is everyone's favorite discussion, money. Dollars per hour, how much money do you make? All right, this is a really good example of a rate, or miles per hour, or any of those things with the word per in it. Okay, so this is the number we often care about. This is the independent variable. Oftentimes, time ends up being the independent variable, but money is what we care about making. So time is an input. How many hours do I have to work to make $400 to buy a new part for the PC I'm building? Or how many hours do I have to work to get a pair of AirPods or whatever? The money is usually what we care about, and then the time is what we compare to see if we work enough hours. So input, or X, is going to be the hours in this situation. Dollars is the output, which is going to be Y. It's the output. We use the variable Y for that. All right, so what we care about is how the money changes, how the Y changes as the X changes. If I work more hours, I should make more money, but it should be a constant rate. Okay, so this means change in Y over change in X. Or what every middle school math teacher ever says, rise over run. So this does give us an equation. Understanding the idea of rate of change is more important than memorizing this equation, but what it looks like is y2 minus y1 over x2 minus x1. If we look at a graph and we know it's supposed to make a line, if we see how the y changes, the difference in y values, divide by the difference in x values, we can see how it's changing over time, or whatever x represents, usually time. So this is the equation we roll with. So for my numbers up here, we would do x2, y2 for the second point. It's okay to have multiple x's and multiple y's. The subscript is what tells us which one's which. So this is point 1, because I use the 1 subscript. This is point 2, because I use the 2 subscript. So these variables are actually different, even though they use the same letter, because I gave them a subscript. So that's how we tell the difference. It's just a little way of keeping the information consistent, I guess. You're going to start seeing more and more subscripts in math as you move forward. Okay, so my new stuff minus my old stuff. Newer is to the right because time from left to right should be increasing. So like this could be 2 years ago or 1 year ago. This could be 1 year in the future, and we're planning ahead. So read it left to right just like you'd read a book. So y2 minus y1 is going to be 5 minus 2. And then x2 minus x1 is going to be 1 minus negative 1. So that comes out to 5 minus 2 is 3. 1 minus negative 1 is 2. That's our slope. So we're able to find the slope from the graph, but also when we have an equation, we can use it to tell ourselves how far we go. Up 3, right 2. So we can use the fraction to graph a line, or we can use the line to find the fraction. So it goes both ways. When you read an equation, you should think of it in terms of the graph, not just the fact that it's an equation. And you can start pairing those two in your head, the picture of the graph and the actual equation, that's when you're going to start being successful with this unit. Here's an example for finding slope again. So which points are newer point, which points are older point? This is point 2. This is the newer one, so I'm going to call it x2 and y2. The older one I'm going to call x1 and y1. So in our equation, we should do new minus old. 2 minus negative 2, the y values on top. 3 minus negative 3 for the x's. And then we simplify. 2 minus negative 2 is positive 4. 3 minus negative 3 is positive 6. That's an okay answer, but when we have the ability to simplify the fraction, 4/6 and 2/3 are the same. I'd prefer we simplify. Smaller numbers are easier to read. All right, I'd really appreciate if no one turned these into decimals, because graphing with decimals is a nightmare. Fractions are much easier to graph with. Let's look at one more. So we've got another graph. The second example for this. Starts at 0, 2. And then the next point is at 2, -1, so maybe like right there. Trying to guess a good spot for these points. All right, so this is the new one. I would call it y1 and, or sorry, x2 and y2. This is the old one. I'd call it x1 and y1. The reason I can tell it's new and old again is because I'm reading left to right. So new minus old. y2 minus y1. -1 minus 2 on top, and 2 minus 0 on bottom. -1 minus 2 is -3. 2 minus 0 is 2. And it makes sense that our fraction is negative. -3 over 2, because the graph's going down as we read it left to right. Finding slope from a table is something we've already been doing this unit. Find your changes. +3, +3, +3. And then the y goes -6, -6, -6. They all match, so we don't have to second guess our fraction. But I write my change in y over change in x. So the slope is -6 over +3. We can simplify that to just -2, because -6 can divide exactly by 3. That's all there is to it. We've been doing this, so I'm not going to go into any more detail on it. The next thing we'll look at is just what to expect based on our slope. If I see a line increasing from left to right, that's a positive slope. That means my output is going up as my input goes up. That'd be like how much money we make working a job. We work more hours, our pay gets bigger. A negative slope is the opposite. Negative slope might be someone trying to lose weight. Hopefully, as days go on, their weight's lower. All right, so maybe this is what they started at, and they're tracking their weight from their start. So they'd want to end up lower than what they started at. That'd be an example of a way to use a negative slope. And there's two more, the special cases. The next one is a legitimate function. It's what would happen if your slope was 0, so if x was missing from the equation. You would get a horizontal line. A horizontal line, we talked about in 3.4, that's a slope of 0. So you'll find this when x is missing. You have a y and you have numbers, but you don't have an x. The opposite, when y is missing, would be a vertical line. So a vertical line is an undefined slope. We don't know if it's going up or down. Really, time's never moving. An undefined slope would be like being able to teleport. This is what happens when y is missing from the equation and we only know x. X equals a number. Okay, so this breaks rules. Fails the vertical line test because it's a vertical line. So slope is undefined because if we did, let's say this is 3 comma 3 and 3 comma negative 2. Let's actually find the slope. All right, if I do 3 minus negative 2 on top and 3 minus 3 on bottom, change in y over change in x. 3 minus negative 2 is 5. That's all good and dandy, but 3 minus 3 is 0. I can't divide by 0. That's why we call the slope undefined. There's not a way to actually calculate it when it's a vertical line. For our last example right now, we're just going to graph an equation, y equals negative 6x plus 1. Okay, so I want to peel my information out. This is m. Y equals mx plus b. So negative 6 is m. All right, we want to write that as a fraction. So if it's not already a fraction, stick a 1 under it. The top number is our change in y. Y goes up and down. Negative numbers are down, so this slope is down 6. Bottom number is run, that's the x. X goes left and right. Positive numbers are right, so this is right 1. Next, we look at our b. We have a plus 1. Okay, that's our y-intercept. So you always write the y-intercept as 0 comma whatever b is. It tells you where to start, up or down. You always start somewhere on the y-axis, and then you go left and right with your slope. So we start at 0 comma 1, that's right here, and then we go down 6, right 1. That's our map to our next points. 1, 2, 3, 4, 5, 6, over 1. We can go backwards too. Up 6, left 1. You can always do the opposite of your slope instructions to find more points. This is a very steep negative slope, but that's how we use the m and the b. Occasionally you'll have other types of problems that aren't initially in this form. So there's another example on this same page that looks like x plus 4y equals negative 10. Well, we just get x alone. It's not too bad. Subtract x on both sides. 4y equals negative x minus 10. Then divide by 4. And I know we don't particularly love fractions and decimals, but there's a 1 in front of this x. So I'm going to pull the fraction out front. Negative 1 over 4x. And then 10 divided by 4, go ahead and use a decimal for the y-intercept. The y-intercept, I think, as a fraction is actually worse. Slope is good as a fraction. Y-intercept is not as good as a fraction. So m is negative 1/4. That means down 1 and right 4. So this is going to be a really shallow slope. It's going to be fairly leveled out. And then this is our b, negative 2.5. So I start at 0 comma negative 2.5. That decimal is not too hard to read because it's just in between negative 2 and negative 3. That's 0 comma negative 2.5. Then we go down 1, so we'll be halfway in between again. Right 4, 1, 2, 3, 4. We can go backwards, up 1, left 4 by doing the opposite instructions. And we get this nice leveled out. It's still a negative slope, but this one's a fraction. So it's going to be pretty leveled out, almost flat. Okay, so we can always rearrange an equation into y equals mx plus b to be able to do this with just about anything. So that's all I really wanted to introduce in the video. Hopefully some of this is familiar from 8th grade for you, but we'll put a bunch of practice time in because this is going to be a really valuable skill for you. So this is something we don't want to let slip under the rug.